Hi friends, this is Atanu Chaudhary of SureSolve. In this second part, we'll take up the SSC CGL solution set 19 on trigonometry 3 from suresolve.com and solve the last 5 questions. Let's solve the first of this difficult set of problems. Question 6 is, if tan theta equal to sin alpha minus cos alpha divided by sin alpha plus cos alpha, then sin alpha plus cos alpha is option A plus minus root 2 sin theta, option B plus minus root 2 cos theta, option C plus minus 1 by root 2 cos theta, and option D plus minus 1 by root 2 sin theta. The plus minus indicates that we have to square up both sides and then later take a square root. But what exactly to do now? We could see the key pattern immediately. If we raise both sides to the power of 2 and add 1 to both sides, sin alpha minus cos alpha whole square plus sin alpha plus cos alpha whole square will turn out to be just 2 in the numerator of the RHS, and the problem will be practically solved. Let's show you. Squaring both sides of the equation and adding 1, we have 1 plus tan square theta equal to sin alpha minus cos alpha whole square plus sin alpha plus cos alpha whole square divided by sin alpha plus cos alpha whole square. Or sec square theta equal to 2 by sin alpha plus cos alpha whole square. This is because in the sum of squares in the numerator, the two middle terms cancel out, leaving 2 times sin square alpha plus cos square alpha equal to 2. So we have sin alpha plus cos alpha whole square equal to 2 cos square theta. Or sin alpha plus cos alpha equal to plus minus root 2 cos theta. Answer is option B, plus minus root 2 cos theta. The problem is solved in no time. Next problem. Question 7 is, if cos square alpha minus sin square alpha equal to tan square beta, then cos square beta minus sin square beta equal to option A tan square alpha, option B cot square alpha, option C cot square beta, and option D tan square beta. We will take the shortest path possible by forming the direct expression in the given expression first. How would we do it? Simple. Just express tan square beta as sin square beta by cos square beta and subtract both sides from 1. Not 1 from both sides, but both sides from 1. We have cos square alpha minus sin square alpha equal to sin square beta divided by cos square beta. Or 1 minus in the brackets cos square alpha minus sin square alpha equal to cos square beta minus sin square beta divided by cos square beta. Or 2 sin square alpha equal to cos square beta minus sin square beta multiplied by sec square beta. Now add 1 to both sides of the first equation. You will get 1 plus cos square alpha minus sin square alpha equal to 1 plus tan square beta, or 2 cos square alpha equal to sec square beta. Surely then, cos square beta minus sin square beta equal to tan square alpha. You just have taken a ratio of the two results. Answer is option A, tan square alpha. If you could see this possibility, you would surely be able to solve the problem wholly in mind in quick time. Next problem. Question 8 is, if tan alpha equal to n tan beta and sin alpha equal to m sin beta, then cos square alpha is option A, m square minus 1 by n square minus 1, option B, m square plus 1 by n square plus 1, option C, m square by n square plus 1, and option D, m square by n square. It's clear from the direct expression and the choice values that beta functions are to be eliminated. We will proceed in the simplest path possible and first divide the second given equation by the first and rearrange. Sin alpha equal to m sin beta is divided by tan alpha equal to n tan beta. So we get n cos alpha equal to m cos beta. Or n square cos square alpha equal to m square cos square beta. Using this third equation and the second given equation, it will be straightforward to eliminate beta function. Square up the second given expression and convert the sine function to cos. You will get 1 minus cos square alpha equal to m square multiplied by 1 minus cos square beta. Or m square cos square beta equal to m square minus 1 plus cos square alpha. Substituting our earlier result of m square cos square beta, you get m square minus 1 plus cos square alpha equal to n square cos square alpha. So, cos square alpha equal to m square minus 1 divided by n square minus 1. Answer is option A, m square minus 1 by n square minus 1. Not so difficult as it seemed then. Next question. Question 9 is, if A, B and C are the three angles of a triangle, then the incorrect relation among the following is option A, cos A plus B by 2 equal to sin C by 2, option B, sin A plus B by 2 equal to cos C by 2, option C, cot A plus B by 2 equal to tan C by 2, and option D, tan A plus B by 2 equal to sec C by 2. In a triangle, the sum of the three angles is 180 degree. That is, A plus B plus C equal to 180 degree. Or A plus B by 2 equal to pi by 2 minus C by 2. The same result will be true for the other two pairs of angles B plus C and C plus A. By the complementary trigonometric function relations, sin pi by 2 minus theta equal to cos theta. Cos pi by 2 minus theta equal to sin theta, and similarly for sec theta and cosec theta. Tan pi by 2 minus theta equal to cot theta, and cot pi by 2 minus theta equal to tan theta. Examining the choices, we find that the first, second and the third relations follow the complementary trigonometric function relations perfectly. But in the fourth relation, sec is not the complementary function of tan, rather cot is. So this is the wrong one. Answer is option D, tan A plus B by 2 equal to sec C by 2. Last question now. Question 10 is, if theta is a positive acute angle and tan 2 theta tan 3 theta equal to 1, then the value of 2 cos square 5 theta by 2 minus 1 is option A 0, option B 1, option C minus half, and option D half. From the complexity of the angle in the direct expression, we become fairly certain that we will get the actual value of theta directly from the given expression. Substituting the value in the direct expression, we will get the final answer. With this idea, we can easily visualize the possibility to form a tan-cot relation from the given expression and then get the value of theta by using the complementary trigonometric function relation. Let's show you. Tan 2 theta tan 3 theta equal to 1. Or tan 2 theta equal to cot 3 theta equal to tan 90 degree minus 3 theta. As cot alpha equal to tan 90 degree minus alpha. Equating the angles of tan functions, you get 2 theta equal to 90 degree minus 3 theta. Or 5 theta equal to 90 degree. Or theta equal to 18 degree as expected. Substituting this value in the direct expression, we get 2 cos square 5 theta by 2 minus 1 equal to 2 cos square 45 degree minus 1 equal to 0, as cos 45 degree equal to 1 by root 2. Answer is option A, 0. This problem can easily be solved in mind. To read the detailed solutions, refer to the article in sursolve.com. Link is given in the description of this video. And please do subscribe to our channel for latest uploads. Thanks for watching.